here's my next video. I'm doing 6 through 10. So number 6 says Abigail gathered data on different teams' winning percentages, so how many games they won, and the average salary of their head coach. So here's her scatterplot and here are her results. Here's what Abigail said. Abigail says there's a weak, negative, linear association between salary and winning. Do you think she's true or false? Well, when I look at that, I think weak is about right. I can tell that I have a trend here, but it's not super close to forming a line. However, I would disagree with Abigail and say that that is a positive association. So I think this is false, and here's why. I just want to change her words here. I want to say there is, and actually I'll just change it here. There's a weak positive linear association between salary and winning percentages. So that's all. She just got positive and negative wrong. So that's number 6. All right, number 7. In the 2014-15 season of the English Premier League, which is soccer, there are 20 teams, and each team played 38 matches. Tia made a scatter plot showing the average number of goals each team scored and how many total matches each team won. Here's what Tia said about this scatter plot. There's a strong positive linear association between goals scored per match and the number of wins. There doesn't seem to be any obvious outliers. All right, well, I would agree with Tia that it's strong. It looks a lot like a line. I would also agree that it's positive and linear. And I also agree that there are no outliers. So I think Tia is saying a true statement. Number 8. A bus company wanted to know if the number of complaints received was a function of the number of buses it ran. So basically, for a bus company, the more buses they use, did they get more complaints? The company carried out a study comparing the average number of buses per hour that were in use for different days and the number of complaints that it got on those days. They want to know which linear equation best describes the model. Well, first, I look at that model and I can tell that it is negative. So I look to see, oh, it looks like all of my equations have a negative slope. Okay, I can't eliminate anyone yet. I look at my y-intercept, and here it looks like it's a little over 40. Oh, they all have the same one, so I still can't eliminate. So I have to go based on slope. Is my slope negative 2/5, negative x, negative 1, or negative 4? So there's a couple ways you can do this. You can do this by rise over run, which is kind of hard here because if I look on this axis, every box is actually going up by 0.5, right? 2 boxes is 1, and on this axis, 2 boxes is 10. So that's kind of tricky. Here's what I would do. Here's my suggestion for you. Pick a point that's really close to your scatter plot here. So like, I'll choose this point that's at about 2.5 right here. Or actually, I can use 2. I'll use the point that's at x equals 2. So that looks to me to be a little under 40, 38 point something. What I'm going to do is I'm going to put 2 in for x in each one of these equations and see which one gives me closest to where I think the actual number is. Okay. So let's see. If I do, and pull up Desmos, negative 2.5 times 2 negative 2 over 5 times 2, and then plus 42. That gives me 41.2. And if I look there, 41.2 would be above here, so I don't know if that's the right answer, so I'm going to cross it off. Let's try if I change the slope to negative 1. So all I'm going to do here is change that from negative 2/5 to negative 1. And that gives me about 40. So 40 is a little lower here. I don't know if it's quite as low as I want, but that's okay. Maybe, we'll see. What if I change it to negative 4? Change that negative 1 to negative 4. I get 34, which, if I look at that point again, looks like 34 is on that line that was graphed. So that's why I would choose this one. I hope that makes sense. You could check another point if you wanted. You could also check a point out here like 8 and see if 8 gave you, it looks like it should be about 10. So let's see. If I change this to an 8 for x, gives me an output of 10, which is that point right there on the line. So you could do the same idea. So if rise over run isn't working, pick an x value, plug it into each equation, and see if it gives you what the line says it should. So now based on that equation that I circled, tell me or estimate the number of complaints if they average 3.5 buses that they're using per hour. Well, buses are on my x-axis, so I'm going to put 3.5 in for x here. So negative 4 times 3.5 plus 42. Hop on to Desmos, tuck 3.5 in there, and I should get about 28 complaints. All right, number 9. This scatter plot and regression line show the relationship between the percentage of American adults who smoke and the year since 1945. Looks like it's a little bit negative there. So what's the best interpretation of the y-intercept? All right, so the y-intercept is right around here. So it says 41% of American adults smoke. I don't know if that is what that means, so I'm going to say no for that. Remember, typically, when we interpret the y-intercept, think back to that Desmos slip we did at the beginning. That has to do where x equals 0. So I want to see if my interpretation here is talking about x equals 0, years since 1945. 0 years since 1945 would be in 1945. All right, the model indicates that 41% of Americans smoked in 1985. Well, I don't know where they got 1985 from, but that's definitely not where the y-intercept is. So B's not right. 1985 would be somewhere out here. All right, in 1945, 0% of Americans were smokers. Well, the 41 is on the percent of adults who smoke axis, so that's not right. It says the model indicates 41% of Americans smoked in 1945. That's actually right, because remember, years since 1945 is being 0 would be 1945. All right, last one for this video, number 10. Ronnie, we're going to go with Ronnie here, went around the laboratory where she works and measured her co-worker's ear circumference. All right, she's a very interesting person. Then she matched her results with each co-worker's age and created the following scatter plots. She probably wanted to see if age really, if your ears kept getting bigger as you got older. So it said the fitted line has a slope of 0.48. That's the m for your equation. What's the interpretation of the slope? So if that's a positive 0.48, remember we want to talk about ear circumference going up. So on average, every year increase in age was associated with a 0.48 millimeter increase in ear circumference. Remember, slope happens every 1 year. Or slope, like it changes every one. On average, each 1 millimeter increase was associated with a 0.48 year increase. That seems a little weird, so I'm not sure B is going to be right, but we'll see. We predict a person who's 0 years old to have an ear circumference of 0.48. Well, if I look at my table here, 0 years old, 0.48 would be down here. That is not what that equation or scatter plot looks like. And that would also be interpreting the y-intercept for the x of 0 here. We would predict a person who's 0 years old to have his ear circumference of 90. Well, that is up there, but I thought we were interpreting this number, so D is not right. For A and B, the one that makes the most sense is A. Every 1 year, your ear circumference got bigger by 0.48 millimeters. All right, one more video to go for this practice.